Okay, hey everyone, thanks for coming out. I was just looking at the stickers on my laptop, and like, since I got all these stickers, half the companies have been acquired by the other half. That means the industry's moving fast. My name is John Harris, I'm a solutions architect for Docker. Today I'm going to be talking about Docker and Kubernetes, so you might have caught the announcement at DockerCon EU 2017 that we're now supporting Kubernetes as a native orchestrator in the Docker EE platform and on Docker for desktop. So just a quick show of hands, who uses Docker for desktop, either for Windows or Mac? Okay. Who uses Docker outside of that, either like Docker Machine or just native on Linux? Alright, pretty much everyone. Good. So I want to go through some of the features that we have in Docker with the Kubernetes integration as an orchestrator. I don't want to do too much slides, I want to do some demos, we'll see how it goes. So I want to show deploying an app to our EE platform, both using Swarm and using Kubernetes. And I want to talk about some of the Kubernetes primitives that we use and integrate with to deploy that. I also want to talk a little bit about developer experience and some of the external tooling, just show it's just plain Kubernetes, upstream Kubernetes. We can use all of the existing tools that we have right now against that. And then I'm going to do a demo of Ingress controls at the end. And if there's time for questions. So, the Docker platform in a nutshell, right? So Docker is the center of a lot of developers' workflow right now. We have developers on one side, operators on the other side. Joe did a great talk at KubeCon on different personas, users of Kubernetes and containers, right? Different concerns for operators, different concerns for developers. Thank you, Nirma. And we have applications at the top. How do we deploy this stuff, right? Do we really need to care about what's underneath, and then infrastructure underneath that? And Docker's like container runtime, we're just keeping all that together. So the core principles of the Docker platform, independence, right? We want to try and get rid of vendor lock-in. We want to allow people to take their applications, containers to one cloud, on-prem. They want to have the same experience everywhere they go. Openness, okay, Docker has a big base in open source, obviously. And simplicity. So one of the things that people love about Docker the most is its user experience, right? It's easy to get going out of the box, and everything just kind of just works. So we hear what customers wanted, right? We hear what the community wanted. And they wanted us to support Kubernetes. So we wanted to try and bring that simplicity, bring the openness, and bring the ease of use and that developer experience to our package while also integrating Kubernetes into that experience. Right? So, what does that look like? Right? So we have containerd at the bottom. So is everyone aware of the rough architecture of how Docker actually works? Containerd, run C, show of hands. Who knows how this stuff actually runs? Okay. By the way, I'm going to assume a fair amount of knowledge here, so I might go a little bit faster. So on top of that, we have Docker Enterprise Edition, which adds a load of security features, some regulatory features on top of the Community Edition, which is what everyone downloads. And then on top of that, underneath that, now we support these multiple orchestrators, right? So we try to support those orchestrators as a seamless experience. So if I just hit one Docker EE platform, I can deploy to Swarm underneath, or I can deploy to Kubernetes underneath, right? So, what is a container orchestrator, right? So, at the bottom we have our machine infrastructure, or maybe not our machine infrastructure if we're using virtual kubelet, right? Machine and OS, container runtimes, and then we're really talking about service management, scheduling, and resource management, right? That's what Swarm tries to do, that's what Kubernetes tries to do. So, right now we support 3 different orchestrators. Okay, so who remembers the original Docker swarms? This is pre 1.12. Okay, gives you a native API into the same API that we have in the Docker engine, right? You just use the Docker CLI to connect to it and manipulate it. High availability, and for that we needed an external key value store, right? So we used etcd or console to keep the state. We also then have swarm mode. Okay, so this is Swarm Kit. This is built into the engine as of 1.12, 1.13. Keeps all the state in the managers, has a RAW store, doesn't need an external key value store anymore, and we have built-in routing mesh and overlay. So a lot of the networking features came in 1.13, and now obviously we have Kubernetes. So Kubernetes works in a slightly different way under the hood, so particularly the networking is different. So in Docker Swarm mode, we have something called the Container Networking Model, CNM, which is specifically how containers plug into the networks underneath. It's pluggable, but Kubernetes uses a different model called CNI. Which assumes kind of a flat networking model for most of the time, and delegates that to plugins. Okay, so we'll see how Docker EE works with that as well. Okay, so I want to just mention really quickly Docker Desktop. Is anyone using Docker Desktop with Kubernetes right now? So is anyone on the edge using it? Okay, cool. So what we're trying to do with that is develop that Docker edition on your laptop so you can have a seamless Kubernetes experience even on your local machine. So think something like Minikube, but without having to go out to a different tool. Everything's just working in the same Docker experience. Okay, Kubernetes and Docker Desktop. If you don't have this right now, don't know about this right now, if you switch to the Edge channel, Docker Desktop, you can pull down this version with Kubernetes, just hit the Kubernetes wheel here, enable it, and then you'll be able to use this functionality. So what does Kubernetes in Docker E look like? So we have a couple of our components at the top, obviously our UI, our dashboard, trusted registry, which is our registry repository, our proprietary component, the Docker CLI, and now we plug in the Kubernetes CLI to that. Okay, so we just expose the Kubernetes API. In our universal control plane, these are all the same pieces that we had, except for now, we have Swarm mode or Orchestrator on the left-hand side, doesn't need a key value store. Docker Swarm uses etcd, and now we also have Kubernetes bootstrapped on that etcd as well. Okay. So, just a piece of trivia. Does anyone know what Docker's whale is called? Anyone? Moby what? Yes. Moby Doc. So marketing were nice enough to give me some, so we're going to have some Moby Molly Doc trivia. Okay? So hands up, who can name the 4 main control plane components in Kubernetes? There's a Moby or Molly Doc at stake.
So there's the API server.
Yes.
The controller manager.
Yep.
The scheduler.
Yes. And the piece without which none of it can work. DNS is true. Truly, it should be etcd. I'll give it to you. All right. So, and we'll see how all those pieces work. So, we actually run all of those components in containers. And we run, so most of those components can be run in containers. Most Kubernetes, if you follow Kelsey Hightower's Kubernetes the hard way, he'll just run all of those components as binaries. Who knows what Hypercube is? This is another Molly Doc question. Yes?
Oh, I know what it is.
Oh, okay, I want you to tell me.
It's a container.
Who knows what it is and wants to tell me what it is? A compiled binary that held all those in one. Patrick, you get one too. So we use Hypercube to actually run all of this stuff, and we use Hypercube to run all of the Kubernetes components inside containers in the Swarm platform. Okay, and we'll take a look at that in a minute as well. We're a conformant Kubernetes distribution, so Kubernetes certification for different distributions came out, I can't remember, 3, 4, maybe 6 months ago now. So Docker E2 is a conformant Kubernetes distribution. So with that, I'm going to get rid of the slides, and let's do a demo. All of this is well tested and should work offline, so just see that open. So I have a cluster already running locally. Okay, so this is Docker EE for those of you who haven't seen it. If I go to my dashboard here, we can see I have. If I go to shared resources, nodes, you see that I have 3 nodes running. Kubernetes node, a Swarm node, and a mixed node. So it's technically possible to run mixed workloads, Swarm workloads and Kubernetes workloads on one node. We don't recommend it because it's really difficult to tell the nodes which resource is being used by the other orchestrators. You can get to resource contention, but you can do that if you want. And I have a Swarm node and a Kubernetes node. So what I'm going to do is cd into my cluster directory. And in my cluster directory, I have all of the components that I do when I pull down a client bundle. So I can pull down a client bundle from Docker E, contains all the certificates I need to connect into the cluster, contains all the endpoint information. It'll set the environment variables for me to get into that cluster. So I'm just going to source source env.sh. Okay, so that should set up my cluster. So now I can do a Docker version. And I can see now I'm connected on my server side to Kubernetes enabled cluster version 1.8. And we can see my networking plugin is Calico. So Docker bundles Calico as this networking plugin. And on the client side, I'm using Orchestrator Swarm. But I'm still connected to that Kubernetes enabled cluster. So I can do a Docker node ls. We can see I have 3 nodes there. And I can also do a Kubernetes get nodes. Okay, I have aliased kubectl to k. We can see I have 3 Kubernetes nodes. So they're both the orchestrators are going to see the same amount of nodes. So let me go through. Let's do it down. Okay, so I have an application which we wrote for KubeCon EU, which is Words demo. Okay, so I have a Docker Compose file here. If I cut out my Docker Compose file, simple Compose file, database, API, which is just going to serve uploads of random words, and a web front end. So I can do a Docker stack deploy, give it a name. I'm going to call this swarm words. Target that Docker Compose file. Hit deploy. And we see that's currently going to hit so we're still talking to the same EE platform here. We're not talking to Kubernetes, we're talking directly to the Swarm piece. So it's still going to go ahead and deploy. It's going to hit the same API server. So now if I go over to my shared resources and look at stacks, we can see I have a Swarm service up here, Swarm words. If I go onto my services, onto Swarm, go take a look at my web, and I've got a published endpoint here because it's specified in my Compose file that I can throw this out. So if I go up and take a look at this, you see my application's running. All of these different blocks are being served by different elements of the API, so you can see their IP addresses change. And so this is pretty basic, right? This is everything we've seen so far. So what's some of the cool stuff we can do with Kubernetes? So what I'm going to do is I'm going to target the Kubernetes API with kubectl, and I'm going to create a new namespace. Call it Kubernetes words. Okay. And now what I'm going to do is, let's open up, I'm going to do a Kubernetes get pods, namespace, Kubernetes words. Do a -w to watch that. Now if I open up a separate terminal, let's put it at the top. And in my separate terminal, I'm going to go and deploy that to this cluster. So I'm going to go just need to go source my bundle again. So source env.sh, so I'm connected to the cluster. Then I'm going to go back into my words demo. So if I did that Docker version, and then I go take a look at my client orchestrator. Client orchestrator currently says Swarm. So what I can do is do an export Docker orchestrator equals Kubernetes. So this is going to tell my Docker client to now target Kubernetes when I want to deploy that stack. So if I do a Docker version again, we can go see this time my client orchestrator is Kubernetes. So I'm going to do a Docker stack deploy, exactly the same command. This time I'm going to call it Kubernetes words. I'm going to pass exactly the same Docker Compose file. And this time I'm going to give it a -- namespace and call it whatever I call my namespace above, so Kubernetes words. Okay? If we watch this top window up here, I'm doing a watch on the Kubernetes API for the pods in that namespace. Currently I have nothing. So when I deploy this, we should see a whole bunch of pods being created, services being created for that namespace. So I'm using the same Docker Compose file, no changes whatsoever, deploying that instead to the Kubernetes API using the Docker CLI. And I can just flip between orchestrators like that. It's going to deploy the same components. So this time if I go back into my EE platform, and I go take a look at Kubernetes. And I'm going to go namespaces, and let's just turn on all namespaces. If I go check out controllers, I can see it's created a deployment for each 3 of my services. They're in my compose file. You can see it's created a replica set for those. And if I go to load balance, I should see it's created a service for the one I wanted to publish. And if I scroll down here, I can see the URL for that. So here I have exactly the same service running from exactly the same compose file, just targeting a different API, targeting Kubernetes API, running in Kubernetes this time on Docker EE. Okay, so that's pretty cool. We utilize something called custom resource definitions in Kubernetes. So that basically enables us to create the stack file or the compose file as a separate resource in Kubernetes. And then we run an operator, a compose operator in the cluster, which watches for those resources and automatically creates them as they come up. Okay, so let's do a different app. So I'm going to show a different app, something slightly different. So, okay. Let's go. So I was at a container event here in Seattle, I think 6 months ago. I can't remember exactly where it was. And I watched Brendan demo his Metaparticle project. And I thought it'd be kind of cool to do a demo of Metaparticle. Back then, I didn't play too much with it because the only port was JavaScript. But let's take a look. Okay, so I have this really simple application. It's written in Go. It's going to be an ad for our Docker birthday coming up soon. So currently, it's just a standard Go application. It's going to run. Just going to run on my client here. So if I go cd to image demo, go run image go. Okay, that's running. So if I come up here, should be able to get to that on localhost. Okay, so we can see this is just serving my local application on my local host. So what Metaparticle does is I can put some annotations, depending on your language bindings, I can put some annotations into the code, and then when I run it, Metaparticle is going to go take that application and automatically deploy it to a Kubernetes cluster, giving me a really nice tight lifecycle as a developer. So I can just write the application locally, I don't need to worry about the service it's going to run on, don't need to worry about the cluster it's going to run on, as long as I'm pointing to a valid cluster on kubectl, I can run the application. So let me kill that one and show you. Sorry, this mouse is kind of lagging. I'm going to open. Okay, so this is the same application in Metaparticle. And we can see, all I've done is basically annotate down here. In my main function, I've got this metaparticle.containerize, and I'm passing a few things. I'm passing a package struct into it, which is going to tell me the name of the image that I want to build this as, where I want to push it to, the repository I want to push it to. And it's also going to say how I want to run this, right? So Metaparticle is a runtime, I give it a port, I give it an executor. So if the executor is Metaparticle, it's just going to use Kubernetes. And replicate. So let's go ahead and run this and see if we can bring this up in our cluster. So let's kill that one. Source this meta setup file, just going to set up some environment variables so Metaparticle knows where to push the image. So you go run. So fingers crossed. So we can see that's building. That's just going to build from an image that Metaparticle defines under the hood. If I'd have chosen, if this had been a new image, I've already built this before, if this had been new, it would have pushed it to Docker Hub. And then what it's done is it's gone and automatically deployed it to Kubernetes. So we can see it's detected some containers, it spun some containers up, and it started them on 9999. So if I go back now to my Docker EE UI, and I go to Kubernetes controllers, we can see now I got a Metaparticle web demo and a replica set. So now if I get onto load balancers, it should have exposed a service for me. So Metaparticle web demo, And if I pull this up, okay, we can now see this is being served from Kubernetes and just a seamless experience from the command line, right? So this is just Kubernetes under the hood, it's just Kubernetes API, any tooling that we can use with Kubernetes, Helm, etc., we can use directly against this. So, last demo, so I have a Compose app deployed in Kubernetes, a Compose app deployed through Swarm, and I have another app deployed through Metaparticle to Kubernetes. So it'd be really nice if I brought in an Ingress controller into this, so I could serve this on a URL, I could do potentially TLS. So let's go and deploy an Ingress controller into our cluster. So I thought, seeing as I'd done the Metaparticle demo in honor of Brendan, I would deploy the Heptio Contour Ingress controller into my cluster. So okay, so a number of Ingress controllers that you can use. The most popular ones are like Nginx or HA Proxy. Heptio make an Ingress controller called Contour, which is written by Dave Cheney. So I'm going to go and deploy that into my cluster. So first of all, I'm going to create a namespace. So Kubernetes create namespace Heptio Contour. Okay, created the namespace. And now what I could do, even though I can hit the Kubernetes API, I can also paste YAML into my UI, right? So if I cap the contour, I'm going to create a service account. So I've got the service account down here. So let me go grab this. If I go into the Kubernetes section and hit create, I can paste YAML into here and choose a namespace, right? So I'm going to choose the Heptio Contour namespace. I'm also going to run Contour as a daemon set, so I have the YAML here is for the daemon set. So push that as well. Okay. And then I can create. So we can see down here in the bottom right hand corner, daemon set, Contour created, service account, Contour created. Okay. So if I go to pods real quick, we can see I've got two Heptio Contour pods here created. Now, who can tell me what a daemon set does? Across every node? More or less, okay. Why do we only have two Contour pods here, even though I've got 3 nodes? Nope. Sorry, did you say 2 managers are Kubernetes? Correct. So by default, they will only schedule on nodes running the same orchestrator type, right? So if I'd have had mixed for all of these, or if I'd have had Kubernetes for all of them, it would have scheduled on all of them. We actually use an admission controller to control what goes where. Okay, so I have this Heptio Contour running. So the last piece, I have this Ingress controller running now, and I have this web server that's going to serve these requests. I need to create an Ingress rule. So let's go take a look. I have an Ingress rule here for my words deployment. So if I cap words Ingress, we can see what I'm going to do is send this into my Kubernetes API, then I'm going to say, if I get requests on this words.kas host, so I've added words.kas to my host file on my virtual machine on my laptop, then forward all of that traffic to the web published service name at this port, right? So I can do a apply words Ingress and hit go. Okay, should have added that. If I go back to my UI, I can go down to load balancers, and I can see an Ingress has been created. So now I should be able to get to that on words.k8s. So let's see if that works. Which is surprising, because it shouldn't. So that's cached, but there we go. That's what I should have seen. So anyone want to hazard a guess as why this isn't working?
Busted your cache.
Sorry?
Busted your cache.
No. So when Kubernetes switched on RBAC by default and everything broke, this is why, right? So Contour needs some RBAC rules. Natively, at the moment in EE, we don't support any resources posted to the RBAC API, okay? Because we have our own RBAC in the Docker EE cluster. We use collections and grants and roles to do that. Similar to the Kubernetes RBAC, but right now we don't support it. Very soon we're going to be supporting any of those resources, but right now what I can do is create a grant in the Docker EE RBAC, and that'll propagate over to the Kubernetes resources. So if I go back to my UI, what I can actually do is go down to containers, and we can see that that is the error. So if we go find one of our contour containers, and we can hit view logs on that container, and we can see here it's just spitting out, failed to listen on this endpoint, okay, access denied. So what I'm going to go and do is head up into my dashboard and user management, go into grants, and I can create all kinds of really granular grants in here, so all the kind of things you do in the Kubernetes API, choose which API, which endpoints, which roles, which users and which groups, all that kind of stuff. Do the same thing in Docker EE. So I'm going to create a grant. I'm going to say namespaces over all namespaces. I'm going to choose the role with some predefined roles, so restricted control is like quite a lot of permissions, but not admin. And then for subject, I'm going to pick the service account in the Heptio contour namespace, and I'm going to pick this contour service account which contour's running with. And then if I go down and hit create, now if I go up to words.kubernetes, you can see that works. And then I also have a metaparticle.kas ingress rule in here as well. So I can just go ahead and do a kubectl apply on my metaparticle ingress rule as well. That's created. And now I should be able to hit my metaparticle instance. .kas. And we see him hitting that as well, and the Ingress controller is load balancing the traffic between the different pods. You can see this is changing. Okay. So that was all I had. In summary, just wanted to run through some of the capabilities that we now have in Docker EE. Just show it's basically Kubernetes upstream under the hood, how we utilize some of the Kubernetes primitives like custom resource definitions, admission controllers, etc. And some of the stuff we're doing to integrate that. So if we've got time for questions, I'll take them when you find them. Anyone questions?
How much load does Kubernetes add to the normal Docker deployment these days?
The question was, how much load does Kubernetes add to the normal Docker deployment? Actually, not that much. Because we run most of the components on different nodes, and just following the standard kind of resource limits for guidance for each component. Sorry?
March 20th, what's that?
March 20th is the Docker birthday, so it's actually exactly 5 years from when Solomon first introduced Docker at PyCon. It was March 20th in 2013. So in Google Fremont, the Docker meetup is going to be there, and it's going to be the birthday. There'll be cake, there'll be a lot of labs to do, and there'll be mentors there to walk you through the labs. Yeah? So EE has a lot of features around some of the content trust signed images. So actually a lot of customers really like EE and Swarm, and they want to deploy things to Swarm, the usability. Different groups and different companies, some have Kubernetes, some have Swarm. We want to try and give everyone a unified experience on top of that. And there'll be obviously some more features coming in EE when we differentiate those products the same as anything else. Sorry? And support, of course, yeah. Any other questions? Cool, thank you.